we've certainly see the people get the biggest benefit where they take a step in with the jigs and fixtures and they start to explore the technology, learn more about it, and actually get a quicker return on investment on the machine itself.
We're about to find out where 3D printing sits today within the world of metal cutting, machining, engineering. So Rob, we're here at Carr-Fullan Group and SYS. You have so much to offer to this industry, don't you?
That's right, yeah, we've got such a wide, broad range of technology that we offer from Stratasys for various different applications across all sorts of sectors. But today, obviously, like you say, we want to talk more about engineering. So I thought firstly I'd explain a bit more about how engineering fits into the various sort of guises of 3D printing, if you like.
Because you have so many different varieties of 3D printing, but through your case studies and success stories, you've always fallen back to one area, haven't you?
That's right, yeah. So we sort of think about 3D printing specifically as a bit of a wedge, really, at the moment. You know, predominantly people are prototyping with 3D printers. That's the major sort of application that people are using 3D printers for at the moment. So think about that as the thick end of the wedge, if you like.
Okay.
And then in the middle of the wedge there, a growing sector for us is jigs and fixtures, you know, be it assembly fixtures, be it masking aids, all sorts of shop floor applications. And then at the thinner end of the wedge, you've got people who are actually using 3D printing for, you know, if you like, the pinnacle of 3D printing, which is end-use parts.
Yes, selling them on from
Right.
there on. So in terms of what you're seeing in the industry at the moment, where are we in the world of metal cutting?
I think the most of our customers at the moment, where we're seeing real success, is where people are joining the wedge, if you like, again at prototyping and predominantly at the jigs and fixtures area. You know, a lot of people think perhaps, you know, or want to esteem to be having selling end-use parts, but of course there's a lot of hoops to go through to get to that level.
And you've said to me off camera, people need to look inside their machine shop and look at what they're doing and how they can improve those areas first before you kind of starting to think about that latter end.
Absolutely. I mean, don't get me wrong, there's going to be applications where end-use parts jump straight out at you, and there's going to be, you know, we've got technologies where we can help people straight away to get to additive manufacturing. But I think you're right in what you're saying there. You know, we've certainly see the people get the biggest benefit where they take a step in with the jigs and fixtures and they start to explore the technology, learn more about it, and actually get a quicker return on investment on the machine itself.
And that's what you want ultimately. Right, so what are we looking at here? Because these are the parts that are servicing the market at the moment.
That's right. So predominantly we're seeing people adopting the FDM process. So that's fused deposition modelling. It's an extrusion process where, you know, there's machines out there for quite low cost, but we sort of sit in the industrial and professional level here. And the reason that we sort of sit there is because of the material properties that we're printing with. And that allows us to actually start to look at metal replacement parts. Specifically, we've got parts that are printed in here the nylon 12CF, which is a carbon filled material. And this has got 35% chopped carbon fibre in there. So on the market, it's got the highest density of carbon fibre in the part itself, which allows us to be able to produce parts such as soft jaws that you can see here, which can actually hold a component in there whilst you're machining it, end effectors for automation, and all sorts of parts that can replace metal components.
And what's fascinating, I'm seeing this and I can see the uses, and I know that someone can just click print on that printer, have that made by the next day. Those soft jaws, they're made, so it doesn't even eat into the working day.
Absolutely. So one of the benefits of the FDM process is its ease of use. There's no particular specific programming required. It's a very clean process. This machine can sit on the shop floor. It could sit in an office area.
Right.
It's very dynamic in the way that it works. So yeah, it's a very easy to adopt technology.
You mentioned carbon fibre. And this particular material, are you coming up against that material? You know, are people saying, I need it stronger, I need it? What are people saying, basically, what they need?
I think we're not seeing really the material failing us. The beauty of additive manufacturing is that you can change the design of the part, not to the detriment of the speed or the cost of the part. So you know, we can put strength into certain areas of this part to beef it up if we need to, and we can actually reduce the weight in certain areas of the part by dramatically taking material off it. Obviously slightly different to the subtractive processes which people are used to working with.
Of course. And a quick case study from yourselves. Have you know, return on investment, where have you got any figures to back all of this up?
Yeah, so I mean, we've got customers out there, you know, we've got some good case study videos which we can share with people for Brown & Holmes and Swift Tool Engineering, where, you know, specifically for one of those there, they've been making huge savings just on metrology fixtures. You know, people can actually take a printed part, put it through to the metrology department and actually write a program around that, reducing a bottleneck in time in that aspect. But also then when the metal part comes through, they've already got a fixture printed and it's ready to go as well. So again, like we were talking about earlier, we're not taking time off the machine tools. That precious time that you've got there to sell to customers is not producing your jigs and fixtures in-house. It's almost giving you more capacity without having to buy an extra machine.
So what are you coming up against? That one question where people go, right, you know, I'm looking at this, or maybe they haven't actually picked up the phone and taken that leap into the world of, you know, fixturing and jigs and fixtures, work holding. With 3D printing, what would you say to anyone?
I think one of the biggest things that we come up against a lot of the time is people perhaps have got an entry-level 3D printer, which proves to them that, you know, 3D printing can have some uses to them. But unfortunately, you know, the reliability and repeatability of those machines probably doesn't sit at the same level as they'd expect from the machine tools that they've invested in. What we're talking about here from Stratasys is a market leader. You know, we're number one when it comes to polymer 3D printing, and we've got a process here which is very stable. You know, we invented this technology about 35 years ago, and so we can give people that reliability and repeatability on the shop floor that they'd get with their other machine tools that, you know, working alongside it.
You know, if you're unsure about any of this, then I can't recommend enough. I mean, you're willing to work with someone, print them apart, that, you know, they send you a design for free just to prove out the process.
Absolutely, yeah. So if people want to come to us, request a part, talk to us about how they can make some savings and reduce those bottlenecks on their actual machine shop floor, then, you know, we'd be more than happy to engage with them. And the end of that process usually ends up with us taking some files, helping them to maybe redesign them to get the biggest benefit of the technology, and then giving them a time and cost report and the actual part itself to give a trial to as well. So we can really help to build a business case to invest in a piece of kit like this.
You've done it before and you've sold machines on the back of it because it has proven to work, and it simply does.
Absolutely, yeah. And we look forward to hearing from anybody that thinks they've got a challenge that we can help with.